Hello, welcome to part 5 of this Asina engine written in Python, coded in Python tutorial, where we're going to make what I've got on screen now. I've actually prepared this one. Can you believe it? I've actually prepared it. So we're going to make sure that our sun is slightly larger, that we've got different colors for the different planets. Probably most conspicuous is we've got kind of a ring. It's pretty good, isn't it? Around Saturn. I haven't put rings around Neptune or Uranus yet. I've made the sun slightly larger. Oh yes, and when we move around using the editor camera, which I'm not doing very well. There we go. What am I doing wrong? I'm doing something wrong. Anyway, if I were doing it right, we can move in and out a lot quicker. It might be to do with the recording. Nope, now it's working. I don't know what was going on there. Right, so you can see we can move a lot quicker towards the planet, and actually it makes more sense for me to kind of zoom out so that you can see the extent of the solar system. Something that is a little wrong here is, or could be, not wrong, but could be improved, is there's Uranus. Is it? I can't remember the order of the planets. Uranus and Neptune. There we go. We've got Neptune there as well, or Uranus. I can't remember which one's which one's further out. Although I could have a look at my where's it gone? Neptune. Oh, I did get it right. Okay, Neptune is the furthest out. Lovely. So I've got my table of data which we used in part 4, I think. It was a long time ago since I made that video. So if you're watching in the future and you're just watching this part 5 immediately after part 4, it's been a long time, so I can't remember anything really from the last video. Right, let's get down to it. So first thing we'll do is sort out this camera thing. And now, look, I can press the X and it works. It shuts down properly. And that's because I've changed my IDE. I'm now in, VS Code, Visual Studio Code. I had to just, what do you use it? In the terminal, I just had to put like pip3 install Asina to get it working again. And then, I don't know, Asina seems to work better. Maybe it was, maybe in the latest release or update or something like that. So maybe it's working correctly in idle. I haven't actually tried. So, this is part 5 prep version. So this is behind the scenes. Let's just go and have a look to remind me. Down the bottom here is where we're going to sort out the camera. So yeah, we call the editor camera now, remember, Smithy. So we can change the move speed. Oh, and then we can change the clip, the far clip plane of our camera to something like 20,000. So that when we zoom away, things don't disappear. So you may have been using Asina and have run into that problem where when you get really far away from things and they kind of like disappear outside of the clip. So we'll sort that out. Right. So I'll go to my. So this is exactly the same code. I've just duplicated it from part 4 so that you can follow along, or my code here will make sense in terms of what you're doing. So, Smithy, when we first create you, we can say move speed, is that correct? I've already forgotten, equals 1000, so we can move a lot faster. In fact, before I do that, let's just cut that. I'll just save the code, and then let's just run it and just see what it looks like as it exists. Okay, so yeah, so everything's green, the sun's really small. I can use the editor camera, and so now I'm pressing forward, and you can see that in the editor camera you get that that little sphere, that little orange sphere, I think to orientate you. That's zooming straight past us, but our solar system is so far away, it's not making any difference. There's that little sphere. So this is not part of our solar system, this is just something the editor camera instantiates automatically to help you kind of orientate. So I'm moving forwards and backwards. But if you look at the planets, they're not moving at all really towards us or behind us. So we've got to be able to move the camera a lot faster. So let's just shut that one down. Okay, so let's go into my prep again. It was move speed, yeah. So move speed 1000, save that, run that again. Now, right click to move the editor camera around. Now if I go forwards, yeah, you can actually see this must be Jupiter getting larger, the sun getting larger, and so we can zoom right into our planets and zoom away again, which is much more satisfying. So we've got more control over our solar system. Right, so let's shut that down. One job done. It's only taken nearly 6 minutes. Oh yeah, I remember having like a discussion last time about that. I won't say this now. Let's just do some more coding. So then you might be thinking, how do I sort out the clip plane? Oh, let me just demonstrate what I mean. So you've got two issues to look at. When you move very far away from things, like that, do you see the way they kind of disappeared? There we go. And it looks really horrible, because part of their mesh is like coming through, and then the engine's deciding which triangles to include and exclude. And there we go. So we've not moved very far away. We can't see the outer planets, Neptune and Uranus, and Saturn and Jupiter and everything else have disappeared. So we need to be able to move further away and still see our objects. And so that's the far clip plane. And then if you move very close to things, I don't think I can hit Jupiter. I'll go straight for the sun. Let's just fly straight into the sun. And so the other clip plane is like that. So it disappears when you kind of go into the object. And so that you can also control. Okay, so that isn't attached to Smithy, our editor camera, but the main camera in the scene, as it were. So the editor camera is more about movement than it is. It's like a player controller rather than the camera in the scene, as far as I can see. So our camera, we want to just write far clip plane, plane equals, and I think 20,000 is good, meaning we can see the far planets. Right, let's just make those far planets a different colour. So all the planets we store on this list, the planets list. So after we've birthed or created our planets, which is underneath here, so birth our planets in loop, add and append them to the planets list. So we make a temporary variable called baby. We store a planet object inside, and then we're changing its solar distance, its orbital velocity and its scale, and then we append or push that temporary object, that planet, onto the planets array or list. So once we've done that, so after this iteration, this loop, we can then pick out each individual planet. So we want to get the 6th planet, is that right, for Uranus? Let's have a look. So Mercury will be at index 0. So remember, don't count from 1. Programmers, we start counting from 0. 0, 1, 2, skip the moon, 3, 4, 5, 6. Wow, I actually got another thing correct. So that's 6. So index 6, and let's just comment on what I'm doing. So colour Uranus white, also Neptune, so that we can see them. So that we can see them. Oh, here's a little tip for free when you're doing comments. Write what you're doing, kind of what this means, but also what's kind of more useful is why you're doing something. And often people don't think of that. Usually you think of a comment as just descriptive, describing what you're doing, but also contextualize it in some meaning, which is really, really helpful. And it kind of like connects the different parts of your program together. So colour Uranus white, also Neptune. So we want to get hold of its entity. Then we want to get the colour of that entity, American spelling, and then equals colour, and I can just use the default inbuilt colour there. Right, I'll just have a look at the class, just to remind you, or remind myself. So this is the planet class that we created. Here's its constructor or its initialization. And yes, we actually made a variable called ent to store the Asina engine's entity object, which is its like 3D object, and that's where we set its model, its mesh, and everything else. Oh yeah, what we'll do for this tutorial is, instead of relying on Asina's built-in models like sphere, quad, planes, things like that, we'll make our own. I've already made it, and then I'll show you how to load that model into Python, which Asina has made really, really easy. Let's just, so I'm kind of sidetracking all over the place. Peter Amland, remember, here's the guy who made the Asina engine. Do go and visit his Patreon, and he's made wonderful. I think he's made it. I'll give him the credit anyway. Cheat sheet, he calls it, asinaengine.org. If you go there, you can find all the information you need. The documentation is really, really good. Right, so let's continue. What was I doing? Oh yeah, I was making Neptune white as well. So we can just copy this code and then let that go white as well, so we can spot them. So now we've changed the far clip plane, and the camera moves nice and fast, so we can zoom out and hopefully we can see our outer planets, namely Uranus and Neptune. So I'm zooming backwards. The far clip plane failed. What's going on there? Right, let's close that down. Go to file save. I've either spelled something wrong or I've not saved it. Let's just try saving and then running it, just before I fiddle around with the code and change something that I need not to. No, I've done something wrong. So I've probably spelled far clip plane wrong or something. Clip plane far. So I have clip plane far. That makes much more sense. Yeah, we're talking about like the main thing, which is the clip plane, and then the final, like the suffix information, just like color.white. No, or rather rotation underscore x, like plane underscore far. The kind of like the most particular thing goes on the end. Okay. Right, save that. Let's try again. How's it already been 13 minutes and I've done like two things? Three things. We've done the speed of the camera, the editor camera. We've changed the color of the planets. Oh, look. Oh, it looks like the moon now. So that's Uranus. And then there's Neptune. So something we could do, I was just thinking about aesthetics of this. Maybe if we detect that we've got a certain distance away from the sun, where our inner planets are basically invisible. I can see them here, but I don't know how well this is going to record and translate. Maybe you're watching on a mobile phone or something, so they're impossible to see. But it would make sense to make them go white, and then maybe to take the texture off as well, so you can just see a pure white. That'd be a good idea. Or to like draw a circle around them, so you can see them very easily. That's maybe a future idea, or an idea to you if I don't get around to it. Right, so the main thing is we put a ring on Saturn. That reminds me of that Beyonce song. So, how do we load a sphere into Unity? Not a sphere, a ring, a torus. So, what I did was the following. So I've gone to my preparation code now. This is the main thing. We create a new variable, we ask for a new entity, and where we say model, where we have asked for a sphere, for example, we just use this function, load model, and then the name of our asset. In fact, I put that in the assets folder, the torus object. Let me go and look at that. Okay, so here's my folder. This is all on GitHub, by the way. I think I've left links to that in the previous videos. I'll try and remember for this one. So if we go into assets, there's my torus object. So you don't have to make that yourself. You could just go and grab it off me, but it's very easy. I have no skill in Blender, and I made that in about 30 seconds. So you just go into Blender, select the torus, click, and you've got a torus, and then export that as an OBJ file. Probably some of the other files will work with Ursina, but object file does work. And that's it. Just make sure your model's centered at 0, 0, 0, and then it won't be offset. So that's where that lives. I just noticed that I just wrote torus. I should have written assets/torus, but Ursina's so good that it just looked through all the folders and things and found it. So that should still work. Anyway, let's write this out in the present one. So after we've birthed our planets, created the 9 planets, after we've coloured Uranus and Neptune, and then before we fiddle around with the editor camera, now we want to create a ring for Saturn. Smiley face. So first thing we want to do is just say ring, and then it equals an entity, and the model is the most important thing, and that's, before we just select anything, load model, and then I say go to my assets folder and then grab torus.obj. So you can make your own models or find your own models online, put them in somewhere in a folder where your main JavaScript file is that you're running, and it will have no problem finding it. There we go. So we've created our ring object, and the second thing we want to do is its position wants to be copied from Saturn. So that's planets. Right, I'm going to work this out without looking at the data sheet. So, well, Earth is the 3rd planet away, so that's going to be number 2. Then you've got Mars, which is 3, Jupiter 4, Saturn's going to be 5. Okay, index 5, and there we go. So we've copied, it's not planets dot position, we've got to get hold of the entity itself. We didn't have to do that for ring because it's not like a planet object, it's just an entity natively like that. Okay, so let's just have a look at that so far. The final kind of step we want to do, no, there's 2 steps. First, I think our ring will be at 0, 0, 0, which is where the sun is. Is it there? I thought I saw it around the sun. No, I'm wrong. Okay, I don't know where our ring is, but it's certainly not going to be around Saturn because it's not going to be orbiting. So one way we can make it follow where Saturn is to parent it, or make it a child of Saturn. And that means it's like you're combining those 2 models in a superficial way. You're not properly combining them. So their positions, their rotations will be shared. Okay, I've forgotten the syntax for that. Let's just going to have a look. Oh, I also scale it. I forgot I did this. I want to scale it to Saturn. I've rotated it. There we go. Ring.reparent2. So that's the syntax there. Okay. So let's go and do that. That's the first thing. Well, actually, I want to kind of sort out its scale. So let's do that here. Scale equals planets, Saturn, ent scale. So it's like the same size as Saturn. Oh yeah, maybe it was really, really, really small. Also, that's just reminded me I've got to change the size of the sun. And we'll finish this video at about 30 minutes, so that's in 10 minutes time. what was I doing? Oh yes, so get hold of ring, reparent to, and then we just put which entity we want to parent to, and that's Saturn again. So I think it's important that we map its position, its scale, and its rotation before we parent it. Because if we like kind of parent it to something, that means it's like attached like this, and kind of fixed, and then if you do things, it kind of messes with its like relative position rather than its world position, I think. Anyway, this way worked, and I haven't tried the other way. So let's just trust that what I'm saying makes sense. So ring, what am I doing? Oh yeah, rotation, x, just to give it a bit of a slant, equals, let's just call it 45. There we go. Right, and I wanted to make the sun really big, and then if I've made the sun really big, it will kind of swallow Mercury and Venus and maybe even the Earth. So we want to push every planet out a little bit more. I'm just going to have a look at my code. This was a good idea, preparation. Who would have thought? Preparation. It's a good idea. It means when I forget things, I can quickly look in here. Right. So where do I make the sun? Sun, scale 964, and then... Oh, is it when I birth the planets? Oh yeah, I just add 964 to the solar distance of each planet, which makes sense. 964. Okay. Let's go and find the sun. Scale. So I just put a 9 on the front of that. 964, and then solar distance. When we're making each planet, let's just add 964. So it pushes them out, so they're not swallowed by the sun. File, save everything. Oh, we haven't squashed the... That was the second thing I needed to do. We haven't squashed the torus, so it might still be quite fat. Or it might look like a... Oh, there was an error. Planet. Reparent to entity. Something's gone wrong with trying to reparent something. Reparent to planets.5 entity, I imagine. Well done if you caught that bug at home. Okay, something's working. So the sun is bigger. Mercury, Venus, Earth, etc. have not been swallowed by the sun. And I'm moving out. Oh yeah, so the torus, or the donut, is too fat, isn't it? You kind of, although it's not got texture, you kind of see it's got a thickness. So, oh yeah, there we go. So what we want to do, so it looks kind of stylized, so you can keep it like that if you want. What we just want to do is flatten the y dimension to 1. And then maybe I'll finish the video there. Oh yeah, the other thing I was going to talk about, so I'll try and talk about this while I'm doing that. So after I've changed its scale, was, yeah, these videos, I've got to relax and just maybe do loads of talking, that's fine. And then other videos, I'll keep to about 10 minutes, where I'm just coding really fast. So I know some people just want the answers. I say some people like myself, sometimes I just want... I just want to find an answer. Say, usually for Unity, something really quickly. And so I'll ignore videos that are like 30 minutes long and just go for something that's like 5 minutes, 10 minutes. Anyway, yeah. I'm kind of talking to myself there. I'm sure you didn't want to know that. Although if you did, and you have some suggestions, put them in the comments. That'd be actually really helpful. So, let's play. See if I've squished the ring. Yeah, that looks flat. Brilliant. Something I did in my preparation was, I know that, well, I think I know, that planets don't orbit in circles. They move in ellipses, they orbit in ellipses. So I just made a fake ellipses. What would be good is to, again, use this data to try, I don't know if it's like from the perihelion and the aphelion. Is this like the nearest kind of point in the ellipse, and this is the furthest point away. Orbital eccentricity, maybe. Obliquity. No, obliquity will kind of be the rotation or something like that. Anyway, so using this data in a way that's beyond my intelligence to work out what kind of ellipse you need. Anyway, the way I just kind of hacked it was in the following way. Let's go to my. I'm sure I just multiplied. Yeah, I multiplied the x value of its polar coordinate by 1.4. So let's do something crazy. Let's do it by like 7. So we go to the orbit function or member function behavior of our planet class, and then we're going to change the cosine driven component of the polar coordinate by 7. And then we should get like really straight or really elliptical orbits. Oh wow, that looks terrible. But also kind of cool. There they go. So I believe we're still looking down from above, as it were, so to speak, although we're in space. There being no up and down. Oh, that looks really nice, actually. But it kind of looks like we're at the side now or something. That's kind of cool. I'm actually going to leave that. That's really nice. Now I feel like I kind of want to change the sizes and stuff. So there's more about the aesthetics. Okay, there we go. So under 30 minutes. Thank you very much. And leave any comments or requests about what you want to see here. And I'll sort that out. One thing I didn't do. Oh, I could just copy it across. Let's just copy across the colours that I used for my preparation. Colour of each planet. So I've got grey, pink, cyan, red, brown, gold, and blue for those planets. I don't know why I'm missing out our final planet, Pluto. I've just ignored Pluto. Sorry. So let's do that after. Let's do that here. I'll replace that colour of each planet. And I think I want to make the ring. Now I'm going to go over half an hour, aren't I? I want to make the ring, if we can do this quickly, ring.color equals, it's kind of a yellow, isn't it? Color yellow. Quickly zoom out. Yeah, so we've got, there we go. So we've got, or is it white? I can't remember. Anyway, I've made my decision. We've got coloured planets, larger sun. We're changing the orbit from a circle to an ellipsis, or an ellipse, sorry. Moving the camera faster, did I say that? And yeah, loading a model in. So it's quite a lot achieved with these like tools. You can do quite a lot. Anyway, right. Thank you very much for watching. We're under a minute before I want to stop. Yeah, leave any comments. That'd be really nice. Goodbye.